Hi, my dear students. Today I have come with another problem on kinetics rectilinear motion. The question goes like this: a body of mass 10 kilogram, this one, is resting on a horizontal table, is connected by string. Now, this body is connected by a string passing over a smooth pulley at the end of the table to another body of mass 5 kg, hanging vertical. If the coefficient of friction between the block of mass 10 kg and surface is 0. 0.2. Now here coefficient of friction is given as 0. 0.2. Mu is equal to 0.2. Determine the tension in the string and acceleration of the system. Now let me explain the question to you first. There is a table on which there is a block of mass m1 which is equal to 10 kilogram. It is connected to another block of mass 5 kilogram with a string, an inextensible string passing over a smooth pulley. Now in the question itself he gave that movement of the block A is in the forward direction. It is in the forward direction. When block A is moving in the forward direction, when it is connected with the string, block B will be moving in the downward direction. Okay, analyzing the given problem and I'll also draw the free body diagram for both the blocks. So because of mass m1 which is 10 kilogram acting in the downward direction, there will be a normal reaction which is acting in the upward direction. Let us take that one as normal reaction n1. Now 5 kilogram is being pulled in the downward direction, that is weight W2 which is equal to 5 multiplied by 9.81. W is equal to m into g. Now tension in the string will be acting in the upward direction. Let us call tension in the string as capital T. Similarly, mass m1 is 10 kilogram, whereas weight W1 will be equal to 10 into 9.81, which is acting in the downward direction. Now as this tension is passing over, the string is passing over the pulley and tension over here is in the upward direction, this block resists moving in the forward direction, movement in the forward direction. That means it always tries to move in the backward direction, or it is resisting the movement in the backward direction. Hence tension in the string capital T will be in the forward direction. Now here both these tensions capital T are equal and opposite. They are lying on the same string, they will be equal and opposite. Now as this block A or block 1 moves in the forward direction, its acceleration in the forward direction we have plus A. Let us assume that acceleration for the first block is plus A as it is moving in the forward direction, and it doesn't have any acceleration in the backward direction, whereas acceleration in the vertical direction is 0. This is acceleration in the x direction. Acceleration in the x direction is plus A, acceleration in the y direction is 0 because it's not moving in the vertical direction. Similarly, for the second block, acceleration in the y direction is minus A. It should be minus A because it tries to move in the downward direction. According to sign convention which I gave you in the previous class, in the forward direction acceleration should be taken as positive, in the backward direction acceleration is negative, in the upward direction acceleration is positive, downward direction acceleration is negative. Right, now here as block B tries to move in the downward direction, its acceleration due to acceleration is taken as minus A. Now it doesn't have any acceleration in the x direction, Ax is equal to 0. Now let me draw the free body diagram of block 1. Okay, we have missed one more force here. So as it resists movement in the forward direction, there will be a frictional resistance, right, which is acting in the backward direction. Now let us take this frictional resistance as capital F, which is equal to mu multiplied by normal reaction N1. So I can write this one as 0.2 multiplied by N1. So frictional resistance F, which is equal to 0.2 multiplied by N1. Now drawing the free body diagram FBD for block A. 10 into 9.81 acting downwards. Counteracting it, we have normal reaction N1. There is a tension capital T which is acting in the forward direction. We have frictional resistance acting backwards, that is 0.2 N1, and acceleration AX is plus A and AY here is 0. These are not forces, it is acceleration. So this is free body diagram for block A. Similarly, free body diagram for block B, as both are connected with a common string. So this is 5 into 9.81 acting in the downward direction. Tension in the string is capital T acting in the upward direction. We have AX which is equal to 0 and AY is minus A. Now I'm considering the entire system in the state of equilibrium, dynamic equilibrium. Now anything which is said to be in the state of dynamic equilibrium, right, it has to satisfy three conditions of equilibrium, right? What are those three conditions of equilibrium? The first condition of equilibrium is sigma fx is equal to ma, or sigma fx minus mass into acceleration along x direction, it is equal to 0. Now sigma fy minus mass into acceleration along y direction equal to 0. Now these two equations are also called as D'Alembert's principles. So in statics, sigma fx used to be equal to 0 and sigma fy is also equal to 0. Now this is in dynamics, and we call these equations as equations of D'Alembert's or D'Alembert's principles, or they can also be called as equations of equilibrium. Okay, now I'm considering block A first. Let us apply the conditions of equilibrium, right? The forces which are acting in the horizontal direction are plus T minus 0.2 N1. Let us take the first equation, sigma fx is equal to my mass into acceleration along x direction. The same equation I have taken with an equal to, so m into ax will go on the other side, that is fx is equal to mass into acceleration along the horizontal direction. So fx is equal to m into ax, right? So the horizontal forces which are acting on this object or this body is plus T minus 0.2 Na. So substituting these things, plus T minus 0.2 N1 is equal to mass m1, that is 10 kilogram, multiplied by acceleration is plus A. So we got the first equation here, T minus 0.2 N1 is equal to 10A. Let this be the first equation. Now let us take the second equation, sigma fy is equal to mass into acceleration along y direction. As acceleration along y direction ay is 0, I can take directly that one as 0. The forces which are acting in the vertical direction are 10 into 9.81 and N1. So N1 minus 10 into 9.81 is equal to 0. Now here I can take N1 which is equal to 98.1 newtons. Now substituting N1 in equation number 1, we get T minus 0.2 multiplied by 98.1 is equal to 10 times A. Or you can also write this one as T minus 10A is equal to 0.2 into 98.1. T minus 10A is equal to 0.2 into 98.1. So T minus 10A, it is equal to 19.62. 0.2 into 98.1 is 19.62. So we got the first equation. Now drawing the free body diagram of the second block again. So we have the second block, weight W2 which is equal to 5 into 9.81 acting downwards, whereas mass M2 in kilograms. This is in newtons, 5 kilogram mass. Next, tension capital T acting upwards. We have acceleration along x direction is 0, acceleration along y direction is minus A. Now considering block B, this is block B. Now applying the first condition of dynamic equilibrium, sigma fx which is equal to mass into acceleration along x direction. So we don't have any forces which are acting in the horizontal direction, hence this equation is ruled out. Next, let us go with sigma Fy is equal to mass into acceleration along y direction. Now we have acceleration in the y direction, that is minus a, it has to be negative. So the forces which are acting in the vertical direction are T and W2. Now I can write plus T minus 5 into 9.81 is equal to mass m2, that is 5 multiplied by minus a, or T minus 5a is equal to 49.05. Let us take this equation as equation number 2. Now here we have two equations. The first equation is T minus 10a, it is equal to 19.62, that is first equation. Now solving both the equations, so we get T is equal to 39.24 newtons, that is tension, and similarly we get acceleration of the system at a is equal to 1.962 newton per meter square. So these are the answers. Thank you.